All right, good news. We're getting closer and closer to running a sample. Thank goodness. Woohoo! Less videos that you've got to watch and less videos that I have to make. Woohoo! We both can celebrate. All right, so we have started the machine up, meaning we turned the power buttons on, we turned the gas tanks on, we checked all the regulators, and we've got our hydrogen generator that is pumping down 1 hour before it can generate enough hydrogen for us to actually operate and use the piece of equipment. In the last video, we talked about turning the computer on and getting it established and making a connection to the instrument. So what are the steps that we go through in order to get to this home screen? And this is where we left off. And it says GC's not ready and the AOC is ready. So I just need to wait. I need to make sure that the GC can kind of stabilize and do what it needs to do before I go and actually run samples for the first time. In the meantime, what I can do, though, is load up some setting parameters. And this is what we are going to be called the method selection. Picking out really what's appropriate for the analysis that I need to run. All right, so that means that when we run blood alcohol, there are tons of settings that can take place in the computer software. Flow rates are here. Flow rates are there. Flow rates are in another spot. How long does it jiggle in the oven? How hot does it jiggle in the oven? How far should the needle go down? How long should it stay in there? How much gas or headspace should it suck out? How much should it push in? Do I take what gets submitted to the column and the tunnel, do I split that again in any form or fashion? How hot should the detector be? How fast should the flames go on? How long should they go? What's the run time? How about my tunnel? My tunnel starts at this temperature. Does it stay at that temperature? If not, it has to gradually increase temperature. It has to get hotter and hotter and hotter. How fast do you want it to hot? There are so many settings in this thing. No one wants to do this every single time. So what we do is that we choose a method, and a method will have all of these settings preloaded, ready to go, because they're not going to change. Meaning, the first time that we run things, we create almost like a Word document in a way. We create a document, and that document has all of the settings that are needed to run it appropriately, and we save it. And that is called a method file. A method file is going to be a document that has all of my settings ready to go. So that way, the next time I need to run samples, I'll just go to that document and I'll just open it up, and all of the appropriate settings are loaded onto the software, so I don't have to keep worrying about it and entering them in every single time. When this method was created, I would say it took 45 minutes to 1 hour just to enter all of the information in and to double check it to make sure that it all made sense. And I don't want to do that every single time. So method selection is very important, and a method file, that is why we use them. So up here at the very top, you are going to see a tab, and the tab says method in the software. Well, guess what? That's not where you go. That's creating a new method, maybe from scratch or something like that, or giving you information about the method that has currently been loaded. So the best way to do this is actually go and under the file tab, not the method tab, under the file, you're going to see, ta-da! Open method file. I mean, I almost was like, open sesame, right? Okay, so open method file will allow us to go in and choose what we want to run setting wise, right? Okay, so again, there could be like 100 different things that we can do with this machine. Every single one of those will have its own settings, and we can go in and save those settings under the method files. That's why we have that option. So we just pick and we tell the machine, hey, I want to do this today. And I double click it, and it will open up and it will load all of those setting parameters on the computer screen software for me. All right, so when I go to open method file, what happens is that I will look at a screen that looks like this. And for us, now, we operate a different way than real life. But for us, we have a folder, and that folder says CTC 210 Forensics. So I hope that makes sense. Because we do use Headspace in other courses, and as of today, the only other course that we see that in is our chromatography course. So that's our CTC 250 class. So I'm going to double click in CTC 210 Forensics because this is probably where I'm going to find all of those setting parameters ready to go for me. So when I double click CTC 210, this is what shows up. So up here at the very top, I can see the main folder. And then there's a couple of other folders that are here. 2023 data, 2024 data, just me playing around with stuff. I'm going to see that folder. These are all folders, though. It's not the actual what we would call method file. But down here at the very bottom, I see two different ones. One is BAC analysis, and one is BAC analysis DP. All right, so this is a modification that we did just to kind of play around with it, see if we could get things processed a little bit faster. But BAC analysis is what we're going to be using for the method file. And it actually will tell us that in directions that we read. So it would say, in the computer, choose the method file named, and it's going to be BAC analysis for us. So that tells me this is what I need to double click on. And when I do that, it's going to load up all of those settings that have been pre-saved and determined by somebody else. So I'm going to click on BAC analysis. And when I do that, it takes me back to the home screen. And the home screen, at the very bottom, or bottom half at least, there are a few tabs that begin to change. And these tabs are going to be titled AOC 6000, SPL1, column, SFID1, and then general. These are where settings take place. It's where those temperatures are inputted. It's where those flows are inputted. It's where the times are inputted. All of that information is going to be in those tabs. And this is what should change, right? So when I open up a method file, these numbers will update in all of these tabs. And I have a habit of just double checking them. I want to make sure that these make sense. I want to make sure that they match the document because I cannot trust anybody. And someone could go in and make a setting change and not know about it maybe, but not tell anybody about it. And if I am the unlucky one, I'm just going to go in and assume everything's ready to go, and it's going to not be. All right, so this is our AOC tab. That's where we're going to start first. And AOC, of course, is the auto sampler. And then down below, we're seeing a box, and that box is going to have some information in it. So that information that's going to be under the auto sampler, these are preset, determined, saved on a different date by a different person. But, and we had to do them actually, but it gives you a quick overview of what those settings are. All right, so for instance, what instrument is it connected to? Do I do the agitation, which is the jiggle, jiggle, jiggle in the Headspace system? How long should we wait? How far should it go down into the sample container? Okay, well, this penetration depth, that's what that was called. If I keep scrolling down, I'm going to see more settings, and it's going to be, okay, well, what oven temperature should be used? And then how fast do you want to shake it? And how long do you want to shake it for? So all of that has to be entered in by someone at a certain point before we do any of this procedure. And then as I keep scrolling down, part 4 of that screen will go into more settings, more things that we have to set, and we have to double check. So as you can imagine, again, I don't want to do this every time, right? I'm going to take a document, someone's made those determinations, we have to follow the way that that is written, and someone goes in and they make sure that those settings are valid. Once that's done, they save it, and that's what we call a method. Then someone else later can take the advantage of opening a method file, and we can go in and we can upload those parameters with the snap of a finger. Injection is going to be the same way. So the method file contains settings that are needed for the injector. These injector settings will be a temperature, a split, which means we don't inject the entire portion of sample, only a part of it. And then as I go on down past that first half of the screen, injector, kind of the second part to the injector tab, as we scroll down, it looks like we've got pressures. We have total flow, which is the amount of gas that the machine's using at 15 milliliters for every minute that the machine is operational. We have a column flow of 1.2 mils per minute, which means inside of the tunnel, 1.2 mils of gas will go in for every single minute the machine is operational. We have a purge flow. Purge just basically means get rid of. And then we have a split ratio. So the split ratio is to take the sample that has been injected and to make it a smaller amount than what has been injected. And this split ratio is set at 9. So I want you to think of this sample that we have injected into 9 equal parts. One of those parts of 9 will be injected and the rest will go to waste. That is what the split ratio represents. So if that split ratio is set at 100, then that means we've taken the sample in 100 equal parts and only injected one of those 100 equal parts. So super, super tiny amount that goes inside of the machine and begins to get analyzed. And here we're working with gas. So all of a sudden, this gas plug is not a lot of sample, actually, if you think about that. And then when we inject that sample amount of gas, 1/9 of it will actually go through and get analyzed. And the other 8 parts are just wasted and shot out of the machine. The column also has its own settings. So here's the column tab. We're seeing a temperature setting of the column. And then as we scroll down that area of the page, we're going to see temperature up here. That's what you saw in the previous picture. But we're also going to see any type of temperature changes that have to be made within the column. And it looks like this temperature is going to stay at 35 degrees. And it's going to stay at 35 degrees. It's going to analyze samples for 10 minutes. And then it's ready for the next sample to be injected. There are times that these temperatures will stay low and then they gradually increase. There's times that these temperatures will stay low and they will quickly increase. And there's times like this one where the temperature stays constant throughout the entire time. If it stays constant throughout the entire time, this is called an isothermal analysis. So iso means the same and therm means temperature. So this is the same temperature and it is starting at a certain temperature. It ends at the same temperature. There's no changes in between. It is a straight up 35 degree run every single time. All right. Next up is the column setting that determines that length. So if I go through and I say, hey, I want to be, 35 degrees and I want you to hold it at 10 minutes. Okay, that's great. That's easy. It's a 10-minute runtime. But if I go in and I start making these temperature changes and I'm like, okay, well, I want you to go to 65 and I want you to heat really slowly. And then I want you to go to 125 and then I want you to get there really, really fast. I'm going to start keying in all of these temperature settings into this thing, right? And that's what the rate column means and the temperature column means. So when I go in and start changing all of that information, well, it recalculates how long this is going to take to run, and it will update itself. So if I do make those non-isothermal runs, which we call gradient, if I make these gradient runs, then what begins to happen is that the machine will update its own timestamp, and it will let me know how long it's going to take for a sample to be processed. And when it does that, it's going to be up here at the very top, right below the main working screen. It will say end time, and it will update itself, and it will tell me how long a sample is going to stay in the machine before it gets analyzed. And then finally, our next tab is the FID detector. The FID detector also has certain temperature settings that we need to be aware of. Right now is the temperature of the FID detector, and that temperature is set at 300. Very often, that detector is always set hotter than the final column temperature. And once more, we'll talk about that in chromatography class when we start talking about these machines and why that has to be. But the FID detector has a temperature dependence, and we've got to tell it how hot do we want it to stay. So that is a constant temperature, a constant heat, and that's 300 degrees for this particular method. All right, so in the next video, we're going to go through, we're going to watch some more videos within the video and go through the motions of the software again, get a little bit kind of closer to analyzing samples, and then show you some videos of how we load samples up and how we let the machine take over.